Hello and welcome to another TechBite video from CMG. My name is Faraj and I'm going to demo parameter definitions in CMOST AI. We have three main types variables in CMOST AI. Most commonly used are continuous parameters. In this case, we have upper and lower limits for the variable, and the optimizer is free to choose any value within that range. The second types are discrete parameters. In this case, we have preset values that the optimizer is only allowed to choose within that range. So this can be real number, say you're choosing the drill bit size for the well radius, or it can be an integer number, like a block address that's going to be your perforation. It can be a text in the case of having different realizations. Those realizations can be saved in different include files, and the name of that include file can be a text that CMOS can choose from. Obviously, the text cannot go into mathematical calculations, so CMOS sets a flag for each of those text or file names. The third types are the formulas. In this case, the values are not automatically set preset. They are inputs into these formulas, which are selected by CMOS, and then there's a script or a formula that to process to return the results. The syntax can be in Python or in JavaScript, and the returning value can be a simple number, like a simple real number, or it can be complex outputs text, like relative memory numbers. We have examples in CMOST folder presenting the ways to create relative probabilities from the Corey calculations. And to define these all these variables, we have options in CMOST. We can either use cedit, which is a text editor, or we can use a special version of Builder. Let's go to the CMOST interface and see how it works in the software. So all the parameters needs to be defined under parameters section. That's located under the parameterization main branch. And we can start defining new variables using the cedit. So if I click on cedit, that opens my CMM file, which is when we start, is usually a copy of your dat file. So if I zoom in, you can see it's the usual data set, and I can parameterize any character within this text. So if in this case we have a well, which is located in the middle of the reservoir, and we are changing the permeability around this well, trying to match the pressure response. So within the box around the well, we can change the permeability, and Builder writes out these keywords. Now the default value is 1. We are going to parameterize this value and see whether changing the perm around the well in the damage zone can help with the match. So if I select the permeability, say let's create a parameter, we select and right click and say create parameter, and we can call this perm mult. So that's my first variable. You can see CMOS automatically created the syntax. These are the flags that CMOS understands. There's a variable inside, and I can use the same syntax on the other boxes around the well to change all the blocks around the well in with the same multiplier. So I can copy and paste these to other values, replace this with the other values. Or alternatively, you can use the Alt key, so hold the Alt key and select all the current values and just Control V and replace all the one permeability multipliers of 1 with the new variables we're defining. On top of that, I would like to also change the extent of one of these boxes. In this case, I'm changing the extension in J direction for the layer 1. So this is the I, this is the extent in J, and this is K. So if I want to extend this a bit further, so instead of 78, let's parameterize 78. And let's call this extend, extend, and that's my new variable defining how extended this damage zone is on the J direction for layer 1. The next variable that I'd like to parameterize is my include file for the porosity. So porosity is coming from this include file, and I'd like to try other versions of the porosity. So select the file name and say create a parameter. I can name this as pore set, and that's my new variable. So I can save this file now, and I can close. That's my first set of variables. Meantime, I would like to also show you the builder interface. So if you click on builder, that's going to open a restricted version of builder. Here you have the builder interface in the back, but you can't do anything. What are we going to use in this case is this 3 view, which gives you access to different parts of the data set. My base data set had used the Cori correlations embedded in Builder to create relative permeabilities. The inputs into those correlations are stored under relative permeability branch. So set 1, you can see these are the inputs into the correlations, and any correlation, any input, you can see the tag attached to. So in this example, we're going to parameterize SWCon, connate water saturations, and critical water saturations. So select the first one, and let's name and press add. Name this as SWCon. That's my new variable defined. And I also like to define a new variable for SWCrit. That's my new variable. That's all I wanted to do. So I say OK, and that's going to save, and I can close this. Now, if I click on import, CMOST is going to read all the flags that we created in the CMM file and import those as variables. So the first one in the list is J extension. So if you remember, that was the block address. The default value is 71, and we have continuous real for block address. That's obviously something we have to change. So I'm going to change this to discrete integer, and I can put individual values here, or I can use this generate button and say generate some integer numbers between 78 and say 90, and we want to cover all the ranges within the right resolution. So if I say OK, that's going to populate those numbers, and now CMOST has choices to make for extension. The second parameter in the list is permeability multiplier. It's by default is 1, and CMOST automatically assigned 25% below and above for the range. Let's cap the maximum permeability multiplier to 1. We don't want the damage zone to have higher permeability than the blocks around. And we are happy with continuous real. It can be any number. The next one in the list is porosity realization. So this is automatically set to discrete text, and we have to provide some valid text for the variable. So if you say insert, I can use this button and browse for the path for these include files. So the first one, the second one, they're all stored under pore realization folder in my machine. So the third one is stored in the same folder. If I say OK, obviously as we talked, they have to have a numerical value. I say 1, 2, 3, and I'm not setting probability, and they're going to be equally probable in this case. The next one is SWCon, and then we have the SWCrit. So logically, there's a connection between these two variables. We can't let them be an independent variable both. So SWCrit has to be equal or larger than SWCon. To get this link, let's first set the SWCon. I'm going to first set the SWCon. Let's choose a range between 0.2 and 0.30. For SWCrit, I'd like to create a link to SWCon. So we add a new variable, which is going to set the increment to SWCon. So SW increment, and let's set a default value of 0, and let's say that's between 0 and 0.1. Okay. So now what I can do is to change the type to formula for the SWCrit and create a link that between SW incremental and SWCon, creating returning the SWCrit. So let's change to formula, and here we can write the code. In this case, it's a very simple summation of two variables. CMOST automatically stores the variable names and some useful mathematical functions library here. So I'm going to use that and say SW increment plus the SWCon is going to return SWCrit for me. We can evaluate and check this syntax. If you say check for errors, this confirms that the value returned to CMOST in this case is 0.2, because SW increment is initialized with value of 0. But during the run, each of these two will have a number, and SWCrit will be calculated on the fly. So that sets all our variables. Just as a side note, because we are using the builder Corey correlations to generate relative permeabilities on the fly, you have to go to pre-simulation command in CMOST and insert a silent builder session into our CMOST study. The reason is that, so now when CMOST sets these new endpoints, a new curve, a totally new relative permeability table has to be generated within CMOST, and that's only possible in silent builder, or you might have a code that returns those total tables. In this case, we're choosing the simpler approach, which is using the builder. So that's all we had to do for the parameter setups. I hope this was useful. Thank you very much for listening.